Almost every piece of electronic equipment has a power supply circuit. The power supply circuit produces the DC voltage needed to operate electronic components. Batteries can be and are used in portable equipment, but in larger systems where considerable power is needed, batteries are an inconvenience and expense. Power supplies convert readily available AC line voltage into DC at some desired voltage level. Diodes are used in power supplies in two different ways. The first way a diode is used in a power supply is to convert the AC waveform into a DC voltage. The second way a diode is used is to provide a reference voltage for the voltage regulator. A diode passes current in one direction and blocks it in the other. It works analogous to a check valve in a water pipe where water is only permitted to flow in one direction. This chart shows the current and voltage relations for a diode. In the forward bias mode, the diode permits current to flow. While in this mode, there is a 0.7 volt drop across the diode. In the reverse bias mode, the diode blocks current flow. If the reverse bias exceeds the diode's reverse breakdown voltage, then a large current will flow and the diode will normally be damaged or destroyed if this were to occur. However, this characteristic can be controlled to the extent that the breakdown voltage can be designed into the diode fairly precisely, allowing the diode to be used as a voltage reference. Diodes used in this way are called Zener diodes. Note the symbol for the basic diode in the upper right-hand corner. This slide illustrates various ways that diodes are marked for ease of identification. Diodes can be connected in an array to provide a full-wave rectified waveform, where both alternations of an AC waveform are converted to the same DC level. This chart illustrates how the diodes function in order to convert the positive alternation of the AC waveform into a positive DC across the load. Note that diodes D1 and D2 are positively biased. Then the negative alternation of the AC waveform is converted into a DC waveform using diodes D3 and D4. The end result produced by a diode bridge rectifier is a full-wave rectified DC waveform as shown on the bottom of the chart. Full-wave signals are much more efficient and easier to filter than are half-wave signals.